All right, welcome back, everybody. So this is just a video going over some problems from section 311. Just so you guys at home know, we've decided to go with today. I'm going to hand out the test review in a little bit. It's already linked into the assignment, which you probably have already found. But I'm going to hand out the test review pretty soon. We're going to work on it today. It is going to be due by Monday. We're going to go over it on Monday and Tuesday. And then our test is going to be Wednesday and Thursday of next week. Exam review workday next Friday, a week from today, and then 3 days of exam review Monday, Tuesday, Wednesday, exam Thursday, Friday of that last week before Christmas break. All right, we had a question about 21, so let's get to it here. Let me review my notes here. Oh, okay, so this is one where we just have to find all of the other hyperbolic functions, right? So let me get my cheat sheet. Here we go. Okay, so first thing I know is that cosine. Oh, let's get a color going on here. Cosine hyperbolic of x is 5/3. Okay, well that means that I could pretty easily find my secant. Hyperbolic secant of x is 3/5. We know that pretty easily. Okay. One thing that we know is that hyperbolic cosine of x squared minus hyperbolic sine squared of x is equal to 1, right? That's one of our identities that we know. So we can say this: 25 over 9 minus hyperbolic sine is 1. We just add over and then subtract. 25 over 9 minus 1 is equal to hyperbolic sine squared of x. Okay, so that means if I want to make this 1 in terms of ninths, that's 9 ninths. So 25 minus 9 is 16 ninths is equal to hyperbolic sine squared of x. So I square root the other side. 4/3 is equal to sine, hyperbolic sine of x. So we got hyperbolic sine now. So hyperbolic cosecant is 3/4. We got 4 out of the 6. And then we take, we want to find hyperbolic tangent, tan of x, tan, by the way, thank you for the polite pity laugh. It's sine over cosine, right? Tangent sine over cosine. So sine is 4/3. Over cosine was given to us as 5/3. What the what? 5/3. Okay, so that's like 4/3 multiply, keep change, flip. 4/5. So that's hyperbolic tangent. So cos is 5/4. 1, 2, 3, 4, and then 5 and 6 rows down. That makes sense? The only tricky part there was using the identity. Using that cosine squared minus sine squared equals 1 to figure out what sine would be. And I think that's the easiest route to take. Are there other routes to take? Probably. But I don't know. That's just the easiest route. Yeah. Sure. Let's take a look at 15. Yeah, 15 is a good one. I like 15. It's a good one. I would say that. I don't know necessarily, but I did now understand for the test. I pulled a lot of questions from the quizzes and the quiz reviews, right? And then because we did not have a quiz over sections 3.9, 3.10, and 3.11, I pulled a lot from the homeworks. Okay, I pulled a lot from the homeworks, and I didn't just restrict myself to ones that we had done. Okay, I took ones that are in the homework set that, you know, maybe I chose not to assign. So any of these are fair game. All right, here we go. I think I announced yesterday that this one was easier if you went at it from the right side, right? It's easier if you go at it from the right side. So here's the route I took. Just start by saying, we got 2 sine h of x cosine h of x. All right. Start by taking sine and cosine as their definitions. So e to the x, sine is the minus e to the negative x over 2 times e to the x plus e to the negative x over 2. Okay, well, if that's multiplication, I have 2 quantity e to the x minus e to the negative x, e to the x plus e to the x, e to the negative x, all over 4. Yeah.
Where does the cosine come from on the left side?
Here?
Yeah.
I am just working with the left side. I'm starting off on the right side.
Okay.
I'm using the right side to try to make it look like this.
Okay.
You know, we're going at it from the opposite direction. All right. So now we have I'm just looking at my notes just to see where I'm going. Okay. Oh, I gotta FOIL that. Yeah, that's right. I gotta FOIL that on top. So that gives me 2 quantity. And honestly, I could take out the 2 right now if I wanted to. 2 over 4, but whatever. First is e to the 2x, right? E to the x times e to the x is e to the 2x. We add the exponents. Outer is x plus negative x is e to the 0. Inner, we got minus e to the 0, right? E to the negative x times e to the positive x would be negative e to the 0. And then last, we have negative e to the negative x times positive e to the negative x. So that's minus e to the negative 2x. All over 4. So that means that we can take 2 times, now those will cancel, e to the 2x minus e to the negative 2x, all divided by 4. Okay, now at this point, let's do that, right? 2 over 4 is 1 over 2. So this is going to leave me with e to the 2x minus e to the negative 2x, all over 2. Now, look at that. That is if I had said, okay, take sine, original sine was e to the x minus e to the negative x all over 2. Look at the left side there. I'm implying that I want to plug in 2x into sine. If I had done that, I would be erasing away this and plugging in 2x. Isn't that what I have? So that really is sine hyperbolic of 2x. Okay. Again, sometimes it's easier to go at it from the other direction, or to go at it from, like, in this case, on that very last step, I thought to myself, okay, what should that look like in the end? Go at, try to figure out what it's going to look like in the very end. Yeah. Any other questions on that one? Yeah.
Who did 13?
Sure. Okay, this one's kind of a tricky one. Okay, I gotta take a look at this one real quick. Remembering what I did. Okay. 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 I think I got it now. Okay. Okay. So cotangent, hyperbolic cotangent or square root of x minus 1. First thing I'll do here is take cotangent and make it cosine over sine. Okay. What is that equal to? You know what I could do here? You know what? I wonder if this will work. I'm going to deviate away from what I did in the key here for a second, because what I did in the key is I just plugged in sine and cosine, like their definitions, and made it like a big fraction over a big fraction. But let's try getting common denominators right now. That might make our life a little easier. Like I was looking at this problem, like why can't we do that? It does work? Then my key has way too many steps. Take a look at this. So I've got hyperbolic cosine squared of x over sine of x minus, okay, if I want common denominators, let's make this 1 sine squared over sine squared. Okay, so that means, oh my gosh, this is so much easier. What the crap was I doing? Right? Yeah. And then what's cosine squared minus sine squared? 1. Why did I do all that work? Which is just, whoa. I mean, my key, like the whole bottom part of the page, is that one problem. Like, oh, look at all those e to the x's. Why the heck did I do that? I don't know. Tortured myself, apparently. Did it work? Of course, yeah, it did work in the end, but why? That's silly. All right. Taking a bunch of time there. What are the questions? Yes? 44?
Yeah.
Yeah. Is this, what is this? Find the derivative? Oh, okay. Yeah, this is fine. Oh. Okay. So I want to find the derivative, which means that this is a chain rule, right? How do I know that this is a chain rule? Well, it's a function with inside another function, right? It's an e to the negative x, which is inside an inverse secant, hyperbolic secant. Okay, so that means this is going to be y prime is equal to, okay, the derivative of secant in here is negative secant I'm sorry. Nope, that's a lie. I was looking at the wrong one. Gotta go down here. Negative 1 over, and then x. Now, the formula sheet says x times the quantity inside the radical 1 minus x squared, right? Our x is e to the negative x. Okay? So this is e to the negative x times the square root of 1 minus e to the negative x squared. Do you follow me there? That's just applying the secant, right? The derivative of secant. Now we have to multiply this by the derivative of e to the negative x, right? Which in our case here is just e to the negative x. But watch out, because I have to treat this like another chain rule. Yeah? When I go to define the derivative, if I just look at d over dx of e to the negative x, well, that's also a function within a function. So this would be like saying e to the negative x times the derivative of negative x, which is negative 1. It's not just nothing. It's negative 1. So I have to multiply by a negative 1 here, which makes this and this like I'm going to multiply those together. So the two negatives eventually cancel out. So I'm left with y prime is equal to e to the negative x on top over e to the negative x square root of 1 minus e to the negative 2x. And then I can cancel out the e to the negative x's. So 1 over square root of 1 minus e to the negative 2x. And I believe, yep, that's what I had in mind. Okay. Other questions? The negative 1 came from the chain rule applied to e to the negative x. Right? The derivative of e to the x is just e to the x. So we take the derivative there, it's just the same thing. And then if I take the derivative of negative x, it's negative 1. So we multiply by the negative 1 out of here. Yeah?
Like,
You would say, okay, d over dx of this, that's what you're asking? It would be e to the 2x times 2. Yeah, does that make sense? Because derivative of 2x is just 2. So this one was actually like a chain within a chain, right? Chain on a chain.
Where did you get the chain from the initial?
Because it was secant and then the e to the n. Yeah. Questions? Anything else? Okay, so let me pass out the test review. Bye, everybody at home. So long. Good talking to you. Have a good weekend.